Have you ever pondered the mysteries of the universe and wondered how NASA is contributing to unravel them? Hold that thought, because it's a journey worth exploring. For ages, humans have been captivated by the celestial bodies that twinkle in the night sky. It's a curiosity that has led us to develop sophisticated technologies and embark on daring missions to unearth the secrets of our universe. At the forefront of this exploration is NASA, the National Aeronautics and Space Administration, a beacon of human curiosity and ingenuity. One of its most ambitious endeavors in recent memory is the Osiris Rex Mission, a spacecraft dispatched to a carbon-rich asteroid known as Benu, tasked with retrieving a sample of its regolith. This mission, rich in both complexity and potential, aims to enhance our understanding of the origins of our solar system and possibly even life on Earth. NASA, through its ambitious Osiris Rex mission, has made significant strides in understanding our universe. The Osiris Rex mission, a 20-year endeavor, was no small feat. This ambitious undertaking by NASA was not just about reaching an asteroid. It was about collecting a sample from it and bringing it back to Earth. The mission aimed to answer questions about the origins of our solar system and, potentially, life on Earth. The planning phase of Osiris Rex, or the origins, spectral interpretation, resource identification, and security regolith explorer, was a complex process that required meticulous attention to detail. The spacecraft was designed to arrive at a carbon-rich asteroid named Benu and retrieve a sample of its regolith, the loose fragmented material covering solid bedrock. But the mission was not without its challenges. Benu was more than 200 million miles away from Earth. The planning team had to account for the vast distance, the asteroid's size, and its speed. Not to mention, they had to devise a method to collect the sample without contaminating it. The goal was to bring back at least 60 grams of sample. To achieve this, engineers developed the Touch-and-Go Sample Acquisition Mechanism, or TAG-SAM, a complex device designed to safely collect and store the precious asteroid material. In the planning phase, every possible scenario was considered, every potential challenge was anticipated, and yet, as is often the case with such pioneering missions, the team was met with unforeseen problems. 2 of the 35 fasteners on the TAG-SAM head were stuck in place, keeping the precious sample out of reach. Despite the unexpected obstacle, the team remained undeterred. They knew that the success of the mission hinged on this sample return, and they were prepared to do whatever it took to ensure that the sample was safely retrieved. The mission aimed to retrieve a sample from the asteroid Benu, a task that had never been done before. It was a monumental endeavor, a testament to human curiosity and ingenuity, and a step forward in our quest to unravel the mysteries of the universe. The journey to Benu was a test of technology, patience, and human ingenuity. Spanning the vast interstellar highway, the Osiris Rex spacecraft embarked on a mission of great ambition and even greater significance. Its destination, a carbon-rich asteroid named Benu. Its purpose to retrieve a sample of its regolith, the loose fragmented material covering solid bedrock. This wasn't just a handful of space dust, but a tangible fragment of our solar system's past. With the hope of understanding our cosmic roots, the spacecraft traveled millions of miles, reaching Benu and successfully retrieving a sample. But space exploration, as any seasoned astronaut will tell you, is rarely a smooth ride. The spacefarers encountered an unexpected hurdle when the time came to unpack the precious cargo. 2 stubborn fasteners, out of 35 on the Touch-and-Go Sample Acquisition Mechanism, or TAG-SAM, kept the coffee cup-sized sample tantalizingly out of reach. The stakes were high. After a journey of such magnitude, the samples of otherworldly dust and rocks, some up to 0.4 inches in size, were priceless. The team had to tread carefully, taking every precaution not to contaminate these ancient particles. This was, after all, a cosmic jackpot, a treasure trove of information about the origins of our solar system and possibly life on Earth. The challenge was formidable, but if there's one thing that sets NASA apart, it's the ability to marry creativity with science, to come up with solutions that are as innovative as they are effective. NASA engineers, with their unwavering dedication and unparalleled expertise, developed a workaround that not only resolved the issue with the fasteners, but also protected the integrity of the sample. The journey was long, the challenges were many, but the spirit of exploration, the quest for knowledge, and the resolve to overcome obstacles remained undeterred. Despite the challenges, NASA's engineers and scientists remained undeterred. NASA, with its innovative thinking, found a way to overcome the fastener obstacle. What seemed like a small hiccup turned into a significant challenge. 2 stubborn fasteners out of 35 were refusing to budge, keeping the cosmic treasure tantalizingly out of reach. But as we've seen time and again, NASA isn't easily deterred. The agency's engineers and scientists huddled together, their collective minds focused on one objective: to retrieve the precious cargo without contaminating it. Months of painstaking work went into designing, developing, and testing new tools specifically for this task. The team's dedication and relentless pursuit of a solution paid off. After countless hours of careful tinkering, they were able to successfully remove the 2 fasteners. With this hurdle finally behind them, the process of retrieving the sample could begin. Eileen Stansberry, Division Chief for Astromaterials Research and Exploration Science at NASA's Johnson Space Center, hailed the efforts of the team. She acknowledged the tireless work of engineers and scientists who, behind the scenes, had managed to overcome this hurdle. And then, the moment everyone had been waiting for arrived. NASA announced that they had retrieved the rest of the sample. The coffee cup-sized treasure trove of carbon and water-rich asteroid material was finally in their hands. This otherworldly dust and rocks, some up to 0.4 inches in size, were the fruits of a mission that had spanned 2 decades. The samples were safely transferred into NASA's non-contaminating storage, joining around 70 grams of Benu dust collected from the outside of the sample head. This far exceeded the original mission goal of bringing back 60 grams of sample in total. At long last, the precious samples of otherworldly dust and rocks were within reach. The Cosmic Jackpot was finally unlocked, promising a wealth of insights into the origins of our solar system and potentially life on Earth. The arrival of the sample back on Earth marked the beginning of a new phase of the mission. Now, with the precious asteroid dust safely in hand, the real work could begin. NASA's team of dedicated scientists, brimming with anticipation, ventured into an analysis that was nothing short of a cosmic deep dive. The first order of business, a quick-look analysis using an electron microscope. This initial assessment was designed to give the team a preliminary peek into the chemical makeup of the sample. But this was just the tip of the asteroid, so to speak. The following month, the team gathered X-ray diffraction data and conducted a comprehensive chemical element analysis. The goal? To confirm that the sample was indeed rich in carbon and water. Why these elements, you might ask? Well, carbon and water are the very bedrock of life as we know it on Earth. Finding these elements in abundance in the Benu asteroid sample could provide invaluable insight into the origins of our solar system and even life on Earth. The findings were nothing short of astonishing. The coffee cup-sized sample was indeed teeming with carbon and water. This was a significant breakthrough, validating the mission's primary objective and affirming the potential of asteroid mining as a future resource. But the sample also held more than just carbon and water. It contained a myriad of otherworldly dust and rocks, some up to 0.4 of an inch in size. Each particle, each tiny fragment, held the promise of untold stories and secrets about the universe waiting to be uncovered. The sample's journey didn't end there. After its initial analysis, the sample was then transferred to pie wedge sample trays, ready for further study. NASA's Johnson Space Center took custody of 70% of the collected sample, stowing it away safely for future exploration. The remainder was sent to the Smithsonian Institution and the University of Arizona, destined for display. In the end, the sample not only met, but far exceeded the original mission goal. The Osiris Rex mission was tasked with bringing back 60 grams of sample. However, it delivered a cosmic jackpot, including around 70 grams of Benu dust collected from the outside of the sample head alone. This was, in every sense of the word, a resounding success. A testament to human ingenuity and the quest for knowledge. The sample not only met, but far exceeded the original mission goal. With the successful completion of the Osiris Rex mission, NASA is already setting its sights on the next challenge. This heralds a new era for the spacecraft, now rechristened as Osiris Apex. The suffix Apex stands for Apophis Explorer, and it's no mere coincidence. The spacecraft's next mission is to reach the asteroid Apophis. Apophis is no ordinary asteroid. It is scheduled to make a startlingly close approach to Earth in April of 2029. In fact, it will get closer to us than the highest satellites orbiting our planet. This close encounter presents a unique opportunity to study an asteroid up close without the need for a long-distance interstellar journey. Osiris Apex's mission to Apophis is expected to take 5 years. During this time, the spacecraft will traverse millions of miles, braving the harsh conditions of space. It's a journey filled with potential discoveries and new challenges. But if the Osiris Rex mission has taught us anything, it's that NASA is more than capable of overcoming obstacles and achieving its goals. The mission to Apophis is not just about studying an asteroid. It's about understanding our place in the cosmos. By studying asteroids like Apophis, we can gain insights into the origins of our solar system and perhaps even life on Earth. This mission could answer some of the most significant questions we have about our existence and the universe we inhabit. Moreover, the mission to Apophis holds implications for our future in space. As we continue to explore the cosmos, we will inevitably encounter more asteroids. Understanding how to approach and study these celestial bodies will be vital for future exploration and potential asteroid mining. The knowledge we gain from the Apophis mission could pave the way for future explorations and even help protect our planet from potential asteroid impacts. The journey of Osiris Apex is a testament to NASA's relentless pursuit of knowledge and exploration. With each mission, we push the boundaries of what's possible, and in doing so, we expand our understanding of the universe. As we look forward to the mission to Apophis, we stand on the brink of a new era of discovery, fueled by curiosity and the desire to explore the unknown. NASA's Osiris Rex mission has been a remarkable journey of discovery. Setting off on a quest to unlock the secrets of our universe, NASA's ambitious plan was met with great success, revealing the cosmic treasures hidden within the Benu asteroid. From the meticulous planning that took 2 decades to the launch, the mission was a testament to human ingenuity and our quest for knowledge. The journey, filled with anticipation and challenges, led us to the carbon-rich asteroid, Benu. Here we were able to retrieve the regolith, a treasure trove of information about the origins of our solar system and perhaps even life on Earth. However, the mission wasn't without its hurdles. The sample, stored in the touch-and-go sample acquisition mechanism, or TAGSAM, proved to be a tough nut to crack. 2 stubborn fasteners stood between us and this precious cargo. But NASA, with its unwavering determination, developed a workaround, ensuring the integrity of the sample remained uncompromised. The result? A successful retrieval of a coffee cup-sized sample rich in carbon and water. These elements, the building blocks of life on Earth, were finally within our reach. This achievement far exceeded the original mission goal, bringing back more than 60 grams of the sample. The mission, however, is not over. Renamed as Osiris Apex, the spacecraft now sets its sights on the asteroid Apophis, which is expected to make a startlingly close Earth approach in April of 2029. This successful mission underscores NASA's commitment to pushing the boundaries of our knowledge. It's a testament to what we can achieve when we dare to dream, plan, and execute with precision and tenacity. As we continue to explore the universe, who knows what other cosmic jackpots await us?